Good morning, everybody. Apologies for the sound snap there. I'd like to welcome you all to track 2 of AppSec Days PNW. Big thanks to our speakers, our sponsors, and our volunteers. Today, first up, we've got Colin Domoney. He's here to talk to you about API security. Colin's an API security research specialist and developer advocate at 42 Crunch. You might be familiar with the newsletter he curates, apisecurity.io. So, we're running a couple minutes late on getting things started. I'm going to make it brief and hand it off to Colin. Colin, thanks for being here today.
Sure, thanks very much. Thank you for inviting me and giving me this opportunity to talk about API security. So as mentioned, I've got a great job. I do developer advocacy and security research over at 42 Crunch. Now, the topic is quite unusual. What is rugged? So I'm going to explain what I mean by rugged and how rugged I think is important, and particularly for API security. We're going to have a look at some of the threats to APIs, and then we get into the nitty-gritty, to the detail of this, where we're going to look at how to do rugged design and rugged implementation and rugged runtimes for your APIs, and some topics on if you want to go and learn more about this. What tends to work nicely for me is if you just ping questions and ask questions as we go, pop them in the chat. If I see something relevant, I'll pick it up at the time. We'll have time at the end to talk. So I've been doing technology, hardware, software for the better part of, rather worryingly, 3 decades now. I started the first half of that career, probably comes from building systems. I come from South African by birth. I worked in the military industry, medical, and I got used to building systems that were what I would define rugged, right? So they were designed to be supporting life emergency systems. And, if we look at where we are now in 2022, software really is the foundation of our modern world, right? More so than ever. Software developers, people who are writing software, they actually have an awesome responsibility in this role. The Rugged Manifesto really calls on developers. It's a call to action for developers to really think about the way that their code is going to be used, right? So your code is typically, and this really applies nicely to APIs, your code will be used in ways that you can't anticipate. Right? So you'll design something, you'll implement it, and then somebody does something else with it. Be used in ways that it wasn't designed, and then, as we know, the software sticks around forever, right? Nothing is ever deprecated. It always exists. And what might have been a quick hack to do something actually ends up in production for a long time. And then the real problem is that the people attacking your code possibly are more talented and more persistent than you are, and probably better funded, right? So developers have to take this Rugged Manifesto. They have to take these principles to heart. So how do we distinguish being rugged from being secure? So the way I like to see this is, secure is just table stakes. It's what you've got to do now to be building and deploying software. And these tend to run down that thing there. We've got the basics like transport security, authentication using standard methods, standard authorization, validating data. This is an OWASP event. I don't have to bang that drum too much. We know the importance of doing this, using standard methods, using API gateways, checking that your code is secure, doing code scanning. And these really are the things that, the way I look at this, is the things you've got to do as a bare minimum, the things that satisfy your regulators, right? Your compliance teams. Those are that type of activity. Now, rugged over on the right-hand column, that's obviously everything we've already got in the secure bucket. And then we've got things that, let's think about this as like making the system as hard as possible, right? As impervious to attack. So we're looking at things like using standard libraries and components, maybe libraries that are known to be secure, right? Let's not be taking chances with using unknown libraries and components. Use defense in depth. Understand what your APIs are. If you've got deprecated or old APIs, get them out of production. Think about your access and abuse cases. Think about things like rate limiting, quotas. Actively monitor your APIs. Think about monitoring bad IP address attacks. Have a look at emerging threats, right? And then obviously think like an attacker, attack your own APIs. And this is really what you do to delight your customers. Right, so that's how I'm seeing that difference. So we try to get people to think about being rugged. Just some quick background on the kind of threats that we're talking about. So there's two things that, just to disambiguate these terms, we talk about API vulnerabilities. And these are really things that we're looking at in the OWASP API security top 10. So these are anti-patterns. These are people doing bad things like forgetting to do authentication, these type of things. And an attacker with the right tools and the right knowledge can actually exploit your API and do something wrong, which will create an error, which will leak data. Now, abuse and misuse, that's slightly different. That's where an attacker will do something with the API in a way that you didn't intend it. We spoke about that when we defined rugged. A good example, let me give you an example of this, is what happened during the COVID outbreak. I'm from the UK, and a lot of our supermarkets, obviously had very limited availability of delivery slots, and people started discovering that they could go and query the calendar for delivery slots with the API, and they went and mined that and then wrote scripts to automatically go and book and reserve slots. Right, so they weren't expecting that was going to happen. The people who designed that API, and it was abused. Right, so the difference between abuse and then actual active exploits of vulnerabilities. You've got a range of attackers, and I often talk about the story. I'm doing some research on building API honeypots. If you go and put an API onto a public IP address range, within minutes, somebody is attacking that and trying to exploit that. So these things are under active attack. A lot of the times it's from people just being curious and messing around with that. Other times you can see that there's active attacks using common recently revealed 0 days. And then obviously we know about things like bots. Bots are particularly well suited to APIs because of the automated aspect of that. And then obviously the real serious stuff, like well-funded nation states. To build rugged APIs, we're blessed with lots of fantastic tools that can do a lot of that automation. So things like Kite Runner, that URL there on GitHub, I'll pop that in the chat maybe during the questions. That's a great resource for tools for doing active exploiting and discovery of APIs. Right, just remember to pop in questions now as we go through this. So let's get into the detail of this. So the first thing that we recommend to build rugged APIs is to start doing threat modeling. Now, as Kerry mentioned at the beginning, I publish a weekly newsletter on API security, and reading through that, it's interesting because you can see that a lot of the exploits that happen are things where people didn't think of the attack surface. They didn't understand, what the use case would be and what an abuse case would look like. They just simply didn't realize, how an attacker could attack that API. There's an example of a parcel delivery company that allowed people to submit parcel numbers and then be given a map showing the approximate region. The problem is in the UK with the map, you can easily reverse engineer the postcode and then the address, and then people were able to go and get the exact details. And then they had a second vulnerability where they were leaking too much information, and they actually leaked the full identity of the customer. Right, so they simply hadn't considered that somebody could have try that attack vector. And if you threat model that, this is something that would come up quite easily. And those understand the assumptions and misunderstandings that people can have in building those APIs. And really what that comes down to for me is think like an attacker. I often talk about the reason that we have insecure code. And I think a lot of this is to do with the developer mindset. They want to be creative. They want to deliver, functional software, apps that work well, that delight the customer. But they don't necessarily think like an attacker. So it's about changing that mindset. And the great example here is, if you're securing your house, you might think that you've got the most secure house possible. Just step outside and accidentally lock your keys in the house. and see how quickly you can work out how to get back into the house, right? So it's about that change in perspective. And this is a very useful thing to do with development teams. I come from a background of having done a lot of code reviews for my sins, a lot of code in investment banks. And, you know, often developers, when you say to them, look, this is what could happen, they don't really believe you. And I think what works well is being able to show them that in practice. So spin up an environment, there's lots of vulnerable APIs, get people to work through that, get them to understand what an attacker would be doing. APIs really are about data, right? They're a conduit, they're the pipe that carry your data. Understand where that data is, understand what is private data and needs to be kept private, understand what else can be made public. Data ownership, you know, data provenance, data governance, these are all important topics. The real take home, if I look at, again, on the apsecurity.io, the vast majority of issues are an API somewhere that exposes too much data, right? There's a reason for that, and we come to that in a second. Understand your environments. So this is particularly mobile. There's a number of examples where the attacker has managed to exploit the API or the environment by attacking the application, right? Assume that your environment is hostile, right? I know there's a talk today on secure secrets storage, right? That's important. Token exchange. What's going to happen if you leak a token? Do you have a revocation process in place? Can you efficiently and safely secure those tokens? There was a Tesla hack that happened recently where an attacker discovered that they could find the locations of arbitrary Teslas around the world, because what had happened, a third-party application, a dashboard, a manager, had been given the key, the primary access token for the Tesla backend systems. And then, of course, that platform had leaked that token, right? And there wasn't a way to easily revoke that and exchange that token, right? So they, if you don't have that in place, you've got big problems. Device integrity and the channel integrity, make sure that you are thinking about, there's another example, Brewdog, the brewery in the UK. They had hard-coded API keys in the app. They thought that was secure, and obviously, somebody just ripped the APK apart, gripped through looking for things that looked like keys, and were actually able to use that to get free access to beer discounts until it was discovered. Now, implementation. So this is the bit where we talk about coding and actually, implementing that API. Jot token validation. There's a lot that's been written about this topic, and there's a good reason for that. Jot token validation seems to be one of these things that trips people up. People forget to do the basics. I think there's a website somewhere, the number of days since a Jot token with no encryption was discovered. All right, so people are making these very basic mistakes. To make make sure that the developers have a checklist. I think for Jot token validation, it's not a complex thing to do, right? It's something that's easily handled with a checklist, with standard libraries, with patterns that you can have in your organization to say, this is how we do things, right? And don't fall victim to some pretty basic things that you can just get right. We've got a publication on Jot token pitfalls to avoid. One of the most common vulnerabilities is broken function level authentication. And this is one of these things where I think, what is happening here is that when developers are writing a functionality, they add a new API endpoint, right? And they copy paste something else and they forget to go and put in an explicit authorization, right? Or they allow access to the wrong type of roles, right? So just be very, very careful about that copy paste problem. Explicitly on every endpoint grant that the permission. Be thinking about, and this is this change of mindset from, functionality and enabling everything to thinking like an attacker. What would an attacker do? One of the first things attackers do is they kind of whiz through all the endpoints and see if they can get access to them, right? Easy to automate that. And there's something that trips people up I would say every 2 weeks, there's something in the wild where it's been due to missing function endpoint declaration. WordPress plugins are probably the number one guilty party here, because often plugins, they run as core, they're running as the WordPress admin role, and they expose APIs, and often they'll forget to authenticate particular APIs. If you're intending something to be anonymous and publicly accessible without being authenticated, make that explicit in your code. Reason for this is when you're doing a code review, it's very easy to understand if that was the intent, if that function is meant to be publicly accessible, or if it's publicly accessible by accident, right? So make that explicit. We've spoken about data leakage and data exposure problems, and this really comes about as a result of our object relational mappers, our things like .NET Entity framework. They're great. They're massive development convenience that helps developers write code quicker. I'm not going to advocate for getting rid of ORMs, but ORMs are responsible for most of the issues that we have with APIs, with excessive data exposure and mass assignment. I'm just going to dive into that for a second. So excessive data exposure is when you leak the entire database object over your API. So let's say that example I spoke about, the shipping company, where they intended to just release to get the house location, and instead what they ended up leaking is the entire user information, including phone numbers, emails, and the like, right? So what you need to do is you need to have you need to separate what's exposed publicly from what's actually stored in the database. And then mass assignment is kind of the inverse of that. Mass assignment is when you take untrusted user input coming in on an API request, and you commit that blindly to the database. So what can happen is, if attackers can guess hidden fields, like is admin, they can actually write that straight to the database. So be wary of that object relational mapper. Explicitly write your own translation layer to your API. This is another very common one. A lot of the frameworks that we use, this is one of these things where the frameworks, it's analogous to that ORM problem. The frameworks are great, right? You can run a Flask API. You can get that up and running and working in a minute, right? And that's what you can do there. So, but it will expose other methods, right? If you don't know what that your framework is doing, make sure that you explicitly disable things so that you remove these unknown endpoints and unknown methods. We spoke about mobile applications. Make sure that you're doing things like hardening that environment. Make sure that you're pinning certificates, that you're fully trusting your mobile application. And just be wary of being able to, have an attacker. It's very easy to pop up a mobile app and put it on a reverse proxy and pull out all sorts of useful information. Make sure that you've got your certificate pinning in place. Again, an OWASP event, I don't need to be telling people about the benefits and power of using standard libraries. Don't write your own crypto functions. Use standard frameworks. OPA, OAuth 2, authorization framework, these fantastic stand on the shoulders of giants. Don't rewrite these things. This is where the mistakes happen. SemGrep is great for finding basic errors in coding, finding things like hard coding secrets into APIs, looking for missing authentication and authorization, finding Jot Token Validation errors. Absolute ton of things that SemGrep can do for you. Just mindful of the time, and I see we have got questions. So things about your runtime, think about rate limiting. Don't rate limit obviously on things like any kind of API endpoint that's allowing password reset or login accounts, and then anything that could be abused, like somebody, like we spoke about that parcel number tracking. You know, if that had a rate limit on that, the attack would have been unviable. So do things like that. Jot token validation, we spoke about that already. Security headers, right? These are your basic transport security. Make sure that these things are all in place. Make sure you're checking for them and that you're actively testing for them at runtime. And then get everything hooked into your standard monitoring systems, right? We've integrated our talking about our product, but we've got my API honeypots are now connecting into Azure Sentinel. You know, this is really powerful to be able to see in real time what's happening across these APIs. And then if you're building on cloud platforms, you know, leverage the protections that those platforms give you. Make sure that you're leveraging your API management and your API gateways as well. If you are interested in the newsletter, I think that QR code should work. And then I'm doing what's going to be a fairly entertaining webinar in a week or two's time on breaches. And this is where we get to look at things that go wrong in practice. And I'll be showing you how easily things go wrong. So with that in mind, let's pop over to the questions. So what are the most important rules aspects that you think should be covered in static analysis? From a point of view of API, so this is a bit of a contentious topic, this. You know, we encounter a lot of people that say, well, we're already using, I'm just going to pick SonarQube, not because I've got something against SonarQube, but as an example, and we don't need to be worrying about things like specific API security tooling. So SonarQube is great, does a great job of finding a lot of your what I would call your more OWASP top 10 oriented things. So it'll find injection attacks or possible weaknesses for injection. But what it won't find is things like that Jot token validation. It won't find things like, you know, time and state type issues where people are doing misoperation of an API. They're using an API in the wrong way. Right, so I think static analysis tends to be, in my mind, unless you can customize rules, you know, it's spoken about, sorry, while I flick through these slides, let's talk about SemGrep. So SemGrep is, well, A, it's free, and then B, a lot of the things that these kind of really basic errors, you can do that with SemGrep. You can find a lot of those things really, really simple to do. So I would start with, if I was recommending something, I'd just start with that, and I'd look for standard patterns or standard, in fact, more to the point, standard anti-patterns. Any other questions? I don't know if folk want to raise their hands, or if they can come off mute or put a question in the window. The question is about the slide decks. I guess, yes, I have no problem. I don't know how we will distribute them. I will probably put somehow I'll get a PDF copy of this onto, and I'll tweet it out. Let me just take you back to, sorry about the scrolling. Right, if you do want to get hold of me, find me on that Twitter handle, ask me questions on there. Yeah, the prototype pollution, there was, I'll have to find that, I'll tweet that as well. I'm trying to think who that was. Somebody got, yeah, a week or two ago. Sorry, a month or two ago, there was something like that, but I can't, because I remember I had to look up what prototype pollution was. But yeah, absolutely. So yeah, now in API security, it's a fun space to be in. You know, we're going to build on what we've learned with web application security. We're just going to do things in a slightly different way. But and I'm also pretty positive about, well, I'm very positive about API security, because you know, the positive security model it means that, you know, we're not dealing with you know, we're not running on a block list. We're working with an allow list, right? We have API contracts. We know what good is, and we only allow good. So yeah, hopefully we're gonna solve this problem. And thanks for the comments. I will share that deck. I'll might have to take a day or two to find out where to put it, but I will share it for you. And thanks for the comments.
Thank you, Colin. Appreciate it. It's great having you by today. Well, if anybody does think of any questions, feel free to enter them into the chat, and we'll see if we can find a way to get you those answers in the slide deck after.